So if we want to get a geometric sequence in general terms, we just take our value an and have that be the value a1, our initial term, multiplied by the common ratio r raised to the power n minus 1. So it actually is very similar to the arithmetic sequence version, where instead of multiplying our difference by the number of terms, we raise our ratio to a power for that number, and then instead of taking that and adding it to our initial, we multiply our initial by that value. But to understand this, and again, it's a lot of notation, but we're learning the language, it's less complicated than it looks. We'll see an example to prove that point. So for this example, we're yet again doing the same sort of thing that we've done quite many times here. We are finding the fifth term in the geometric sequence with first term -3 and common ratio 6. So for this, we are working around, well, n equals 5. Our initial term here is a1 equals -3, and our ratio r is going to be equal to 6, which means that we want to find a5, which is going to have form a1 -3 times r 6, oh boy, raised to the 5th power. So we need 6 raised to the 5th power multiplied by -3, which is going to be -3 times 7776, and you can check that for yourselves to be sure, but what we'll end up with here is going to be the value -23,328. And the next thing we're going to look at here, because you've seen this stuff, we've seen it already a few different times, is how we can actually use these things by taking sums, because the sums of geometric sequences actually lend themselves very nicely to real-world applications, especially in the context of things like interest that we're going to see next.